Hello everyone, welcome to this video on solving trigonometric equations. So it's a skill we're familiar with, but we are going to take it a little bit further and introduce you some new notation. So we'll get it straight into this example. Now I don't have my unit circle with me, but fortunately I know the unit circle off by heart. But you guys can refer to your unit circle here and I'll illustrate to you where to find them on the unit circle diagram there. So we've got 4 sine x take 4 is 0. So what we're going to do is isolate sine x by itself first. We're going to get sine x is 1, okay? And then you're looking at your unit circle, and we've got from minus 2 pi to 2 pi. Okay, so here's the unit circle, right? And here would be the angle 0. So if we're going back 2 pi, okay, so that's going to be minus 2 pi is one whole revolution back the other way. And then positive 2 pi is going to be one revolution around this way. Okay, and sine x equals 1 at this point here. Okay, so we know on the positive revolution, if we're starting at 0 and going around, that angle is going to be pi on 2. So what we've got here is we've got x is pi on 2. But if we're starting here and going back the other way, the negative angle, what's the negative of this? Okay, the negative angle there is negative 3 pi on 2. And so there are two solutions that satisfy this statement. 4 sine x take 4 is going to equal 0 at x is pi on 2 and negative 3 pi on 2, because we're going that way. Pi on 2 to there, pi on 2 to there, and then another pi on 2 units to take us the three quadrants through to this point where sine are the y values, where sine is positive 1. So we're familiar with the process, but maybe the sort of going backwards around the unit circle might be a bit of a challenge or a bit new for us. Okay, here, 2 cos 2 in brackets x take pi on 4 plus root 3. Now, I've fixed this. I've had to print it off because I didn't bring my booklet home with me. But I think I put the root 3 at the front here. So this is how it should be written in order for us to generate an appropriate solution. So 2 at the front and then the root 3 there. So if your example is different, change that for me. So what we want to do here, the first thing, again, we'll move this positive term over the other side. We're going to isolate the cos of theta by itself. So we'll have 2 cos of, and let's perform that expansion all in one go as well. 2 cos of 2x take pi on 2. Okay, that 2 distributes to both of those terms in brackets. And we've got equals minus root 3. And now we know as well, whenever we multiply, we've got 2x here, which means we need to multiply the region by 2. So we're going to have minus 2 pi is less than. And in brackets here, okay, what we've got is 2x take pi on 2. Okay, so we're applying that whole thing to the region here. 2x take pi on 2 and then less than 2 pi. Okay. So because we've got this minus pi on 2 here, we need to change the region accordingly as well. And so if we want to get the x by itself, the region we're going to investigate, we need to add pi on 2 to both sides of the region so that it can cancel it. If we go plus pi on 2 here, it's going to cancel it. Okay, so if we have minus 2 pi plus pi on 2, that takes us to minus 3 pi on 2. Okay, so you'll notice I'm starting to do some of these fraction operations pretty quickly. So, my assumption is that we're getting reasonably confident with them now. I don't want to waste time or paper detailing them, and you can perform them on your calculator. And over here, we've got 2 pi plus pi on 2. That's going to be 5 pi on 2. Okay, so we've got the boundary over which we're interested. Now let's again isolate the theta by itself. So we're going to have cos of 2x take pi on 2 equals minus root 3 on 2. Okay, we divided both sides by 2. And here's the boundary we're interested in. Now I'm going to draw the unit circle here. We're interested when cos is minus root 3 on 2. So cos are the x values, and the x values are minus root 3 on 2 here and here. Okay, now in the negative revolution, we're starting at minus 3 pi on 2. So that's 3/4 of a revolution in the negative direction. So we are starting here. Okay, we're starting at this point and we're going around to there, and then we're going around till we get to 5 pi on 2 or 2.5 pi. So if this is the angle 0, we're going minus 3 pi on 2, and so these are our first two solutions. We go past them both. And so if we've got a negative revolution how much have we moved from here to here? Okay, if we've moved from here to this point where the cos value is minus root 3 on 2, the first answer is we've moved an angle of minus 5 pi on 6. That's going to give us that solution. Okay, so here I've got 2x take pi on 2 equals minus 5 pi on 6. Okay, so that's our first solution. But then we're getting to the second solution. How much have we moved in the negative direction to get to this second solution? The answer is minus 7 pi on 6. So there are our first two solutions in the negative direction, okay? And we know we're going around to that way. Then we need to consider the solutions in the positive direction. Now I might draw another unit circle here. So that's the negative direction we've considered. And then the positive direction, okay, again, we're starting at 0 and we're going all the way up to 5 pi on 2. Now 5 pi on 2, that's 2.5 pi. So we're going around 2 pi and then half another rotation, okay? So the whole way around is 2 pi and then half of a pi takes us to this point. So if we think of these as our solutions, we're going past them once on the first revolution, and then we're not going past it again. We're just going up to that point. So we're only going to add two solutions in the positive revolution. And so in the positive revolution, this is the first solution we encounter. Okay, again, we're thinking of when is cos negative root 3 on 2? It's at this point in the positive revolution, which is an angle of 5 pi on 6. And then the next one is at this point in the positive revolution, which is positive 7 pi on 6. Okay, so there are our four solutions, but remember we've got 2x take pi on 2 is equal to these four solutions, and we're trying to isolate x by itself. So what we're going to do is we're going to add pi on 2 to all of these solutions. So again, you can go ahead and use your calculator or perform those fraction operations in your head. I'm going to do them quite quickly. We've got minus 5 pi on 6 plus pi on 2. So that's going to be minus 5 pi on 6 plus pi on 2. Minus 2 pi on 6, and then we've got minus 4 pi on 6, we'll have 8 pi on 6, and 10 pi on 6. Okay, so that's 2x, but then to get x by itself, we're going to go through and divide all of those by 2. Okay, and so that's just changing the denominator to 12, and then I'm just going to write it in simplest terms. So this one will be minus pi on 6, minus pi on 3. This will be, what's that, 8 pi on 12, so 4 pi on 6, so 2 pi on 3. And this will be 5 pi on 6. And so then there are our four solutions. Okay, we can't simplify them anymore. That's a 2 pi on 3. So that was quite tricky, okay? Quite tricky considering the negative revolutions, but not not a process that we haven't seen before. We have seen this before. It's just considering the negative revolutions and how far we're going in each particular direction. Other than that, that's some skills I would expect us to be able to perform. The other way we're going to take this a little bit further is when we have the reciprocal trigonometric ratios. So here we've got root 3 cos of x, cosec of x on 2 equals 2. And this is some new terminology here as well. This is set notation. So all that means, it means exactly the same. So we've got the square brackets. It means including between 0 and 2 pi. Okay. Now root 3 cosec of x on 2. Now what is cosec of x? Cosec of x is 1 on sine of x. Okay, that's what the reciprocal ratio of the sine function. And so what this means is root 3 times 1 on sine of x on 2 equals 2. Okay, so let's show you how we're going to solve this one here. Well, that means 1 on sine of x on 2 equals 2 on root 3. We can divide both sides by root 3 to move that over the other side. And then we can we can perform the reciprocal to both sides. We can flip both sides of the fraction. And then what we've got is we've got a lovely sine of x on 2 equals root 3 on 2, and we're away for the hills. Okay, this is very easy for us to solve. Now x on 2 here, I'm just going to make one more step for you guys, is half of x. And so then we're going to multiply this interval by half. We've got 0 is less than half x, which is less than pi, which means we're only considering half a positive revolution. If we think of, here's the unit circle, sine is the y value, it's positive root 3 on 2 here and here. So that's going to be pi on 3 and 2 pi on 3. And so what we've got is we've got x on 2 equals pi on 3 and 2 pi on 3. And then to write those solutions as x by itself is going to be 2 pi on 3 and 4 pi on 3. We're multiplying both sides by 2. And so these are the two solutions that satisfy this equation. We started with cosec of x, but we were able to rearrange it to something we're a little bit more familiar with. So you can see, look, we've done that before. Here, process has been done before, but increased complexity because of the backwards revolutions. And then here, like not real familiar with the reciprocal ratios, but once we see we can write it in terms we're familiar with, we're off to the hills. So that's exercise 4D. Good luck with that one.